Hello friends, today I am going to give you a presentation on my project Advanced ICU Patient Monitoring with system Sensor Integration, IV Detection with Canny Detection and ECG Monitoring with live feed. These are the contents which we have gone through this presentation. Introduction. We know that the ICU is the sickest patients were treated, and it is crucial to have the accurate and timely monitoring for the vital signs and the physiological parameters. The latest advancements in the technology have made it possible to develop the advanced patient monitoring systems that are capable of providing the real-time data, enabling the physicians and nurses to make informed decisions quickly. The advanced patient monitoring system is designed to provide comprehensive monitoring of patients in critical care. The system includes sensor integration to measure various vital signs, IV detection, using Canny detection, which can detect the level of fluid present in saline, and ECG monitoring with the live feed. These features provide physicians and nurses with real-time information that can be used to quickly diagnose and treat any changes in patient's condition. The advanced patient monitoring system is not only efficient but also reduces the workload of the healthcare professionals, allowing them to focus on providing better care for the patients. The system enables continuous monitoring of the patient's condition, reducing the need of frequent manual checks by the doctor. Problem statement. As we have discussed, in the traditional monitoring methods can be time consuming and may not provide real time data, leading to the delays in the diagnosis of the treatment. As we have said, nurses actually take the vitals of the patient continuously, and through the sensor integration the nurses time in taking the vitals can be used in monitoring the patient's health. Furthermore, the workload of the healthcare professionals in the critical surgery is significantly high, and need for more efficient monitoring systems is essential. As we have the current pandemic situation has further highlighted the need for the advancement of monitoring systems. As we have seen that the COVID-19 is a pandemic situation where we actually had the requirement of advanced monitoring systems to reduce the healthcare professionals' workload, as they have worked for so many hours and days continuously to provide accurate and timely data. Objectives of of our project are as follows: to reduce the time taken to note the basic vitals, the system helps doctor to check patient remotely, to continuously monitor the patient, to detect the IV fluid level by image processing, to use video live streaming techniques for ECG monitoring, to provide real-time dashboards and alerts. These are some papers which we have referred to develop our project, and this is the methodology. The methodology is as follows. The first step involves in choosing the sensors required to know the patient's vital data. It is, if at all a patient suffering from a disease, there are some general basic details where we actually keep in with us, that are the temperature and the blood oxygen level and body resistance, everything. These are the major values which we actually take from every patient continuously. So we have integrated this through the sensors, and the sensors will actually continuously take the data and display it on the web page. There is also a saline which is also referred to the intravenous fluid that should be monitored. Intravenous fluid is monitored through the camera using which actually was trained on a data set which consists of saline images, which helps the uh, machine learning to detect the saline and also the fluid level of the IV. As we mentioned, the first requirement of the sensors, but when we go for the ECG sensors, it becomes costly and less efficient. So to reduce the problem of ECG sensor, the camera of live feed can be used to continuously live feed the ECG model. So to as the ECG sensor is costly, we have kept another camera at the ECG, which is a live feed camera, where the doctors can see the live feed of the ECG, which is cost efficient, we thought. And Max 3000 is the blood oxygen level sensor, which measures the blood oxygen level. And the body resistance sensor is the skin resistance sensor, which actually detects the sweat sweat resistance, which is high or low. And the temperature sensor measures the temperature. And these three are the sensors which we used in our project. And there's a GSM module which is used to provide the alerts based on the blood oxygen level and the temperature levels and the IV fluid level. IV camera is used to detect the IV fluid level, and it will display on the web page. And these three sensor values will also be displayed on the web page through the Arduino and the laptop. And ECG camera live feed will also be displayed on the web application. This is the flow chart. First of all, we will open the web application, and in the user login, the doctor will be logging in with his credentials, and we can add the patient details like multiple patient details, and the patient details will be has to, stored in the backend of the project, and every patient will be monitored with his temperature, skin resistance, and SpO2 values, and ECG and IV level values separately. And you can see there is a limit for the temperature and the IV level and the SpO2. If at all values are within these limits, then the alerts will be produced through GSM through SMS. And this is the sequential diagram of our project, and this is the implementation. Firstly, in the implementation, our main work is having in web application development. The web application is developer or generated by the Visual Studio. There is a Visual Studio software where we developed our project in the software. The HTML and CSS and Java languages are used to develop the web application. From the Visual Studio Code, we have generated a local host which will pop up a dashboard interface. The information from the sensors and the cameras are being used to shown in the developer web application. That is, the sensors information and the IV level fluid level information and the ECG monitor are brought into one roof and being interfaced to the web application which we have created. And the CSS is used to design and arrange the HTML boxes, and Java is used in the operation of buttons in the web application. This is a piece of code from our project which shows that the get sensor is actually getting reading the sensor details continuously of the patient, and this is the login data which we have created for the I mean which we have created for various patients. We can actually store the multiple patient details, and this is a simple this is the dashboard. This is the web page how it look like, and these are the heart rate and blood oxygen level and temperature and body resistance dashboards where the values will be sensor values will be displayed. And in the image processing technique, we have used YOLO V5 technique, which actually is a better and efficient technique in detecting the in the machine learning in detecting the objects or whatever. When detecting the saline, we have actually trained the data on the saline images and some other random images also. When we are testing, we have also given the same saline level images and the random images. which actually helped us in detecting the this YOLO Wi-Fi technique actually detected in helping the saline bottle, and using Canny detection and the offline transform the saline level, the fluid level in the saline bottle is detected through the offline transform, that is the longest line in the saline will be taken, and from that line the IV level is measured through the Canny detection. This is the use case diagram of the image processing, I mean of our project. This is hardware requirements which we have used in our sensor, I mean in our project. GSM module used in producing the alerts. Skin resistance meter is the sweat sensor, and the temperature sensor is the DS18B20. There will be some other sensors also available for the temperature sensor. We have used this one. Max 3000 is a heart sensor or the blood oxygen meter. That is the blood oxygen level uh, reader. Buzzer is used for the alerts, producing the alerts. This is the web. You can see in the figure 6. This is the web page. I mean, starting of the web page where the doctor will be given the login details, and will be logging in, assigning in to the portal. And this is the patient admission form in the figure 7, where the patient details are stored in a form. And in the figure 8, you can see that the patient information is stored like this: the test and age, gender, address, and phone number and symptoms. And the figure 9 and 10 represents our final project dashboards, where the IV fluid level in the figure 10 you can see. In the figure 10 you can see IV saline bottle, where the saline level is shown, and the ECG also was live feeding. And in the figure 9 you can see that the heart rate and the blood oxygen and temperature and body resistance, these are represented in dashboards. And in the figure 11 you can see that there are some alerts which we have produced through our project, like the temperature level is high, about 100 degrees. These are the alerts produced to the, we have sent to the mobile number, registered mobile number. And the coming to conclusion and future scope, the sensor integration allows the monitoring and wide range of vital signs, including blood pressure, temperature, and oxygen saturation. And the respiratory rate. IV detection with the Canny detection technology can detect the IV fluid level with a high accuracy and reduce the risk of complications. Though coming to the future scope, the ECG monitoring, where we have actually stepped up a back for the cost of the ECG sensor, can be implemented if they are if you are affordable with the ECG sensor. You can buy the ECG sensor, and you can get the more accurate data from the ECG sensor. The system for future scope is also enormous, as advancements in the technology to continue to improve the patient monitoring capabilities. Additionally, the use of remote monitoring and telemedicine can expand the system's reach beyond the ICU, enabling healthcare professionals to monitor the patients or other healthcare settings. In conclusion, the advanced ICU patient monitoring system with sensor integration with the live feed can significantly improve the patient care in the critical case. The system's future scope is vast. There are some major uh, technologies that is deep learning and neural network and artificial intelligence, which we are as a booming technologies. We can actually integrate more through these technologies, and we can improve the patient's outcomes and improve the system in the future. Thank you.